statement 4 don't necessarily imply that AB is equal to A.
Yes, statement 2 and statement 4. So what is statement 2? AP congruent to AQ. AP congruent to AQ. Okay. And 4. PB congruent to QC. It does not imply that AB congruent to AC. And why is that?
Because in my case, P was falling outside of A, not on AB.
Oh, that is maybe, I mean, look at the figure that I have drawn. Right? It's a rough figure. And you get
But
triangles like
it can be outside too. So
it can be
in
outside
that
too.
way,
All right. So maybe I'll say if it is not an obtuse angle triangle, then it is true. Will you agree?
I'll think about it.
Yes. But good point. OP. So if you are having an obtuse angle triangle, right? That was your triangle, I'm guessing.
Yeah, right.
So let's say that. But then still, the perpendiculars will lie inside, no? From O.
My O is out in the exterior too.
Okay.
Or in the
Arham. Raise hand, I'll follow.
sir,
Yeah.
I don't know if I'm right or not, but sir, I saw that the perpendicular bisector EF does not originate from a vertex. So, sir, it cannot be used to prove congruency.
It does not originate from a vertex. What do you mean? I'm not saying it is originating from a vertex. I'm saying this is AD and this is EF. Wherever they are meeting, you want this as P, I'll name it as P. If you think O is
No,
for
sir,
origin.
but usually,
Wait, Arham. Yes.
sir, but usually in a triangle, the perpendicular bisector originates from a vertex and is drawn to the line opposite to it. So I think that EF should come from A.
All right. So your point is, from what we have seen, this is not true. That's your point, right?
Yes, sir.
But you still are not finding out what is the problem in this. You're saying that, oh, this is, maybe I'll say, maybe I have not seen that video. Tell me what is wrong in this. Are you getting my question?
Sir, may I tell, sir, what he said?
Yes, wait, let me finish with Arham. Yes, Arham. Are you getting my point?
Yes, sir.
Okay. Kavin?
Sir, in the third point, you're saying that POB is congruent to QOC by RHS, and AOP is congruent to AOQ. In the second point, in the second or the first point. So that doesn't mean that AOB will be congruent to AOC.
AOB will be congruent to AOC.
To make it an isosceles triangle.
No, what is my argument? See, first I'm proving that OP congruent to AP congruent, OP congruent to OQ.
Okay.
I use that to prove that triangle OEB is congruent to OEC.
Okay.
From that I get OB congruent to OC.
C.
And before that I also got AP congruent to AQ.
Okay.
And then I show that triangle OPB is congruent to triangle OQC.
Okay.
So I get PB congruent to QC.
You get PP congruent to QC. But AP should also be congruent to AQ, right?
Look at point number 2.
Point number. Okay.
Corresponding sides of congruent triangles.
Okay.
Dikshant.
Sir, I wanted to ask in the starting means where you have written the question, it should be angle bisector of DAC
because I was confused.
Yes.
there.
Yes, it should be angle bisector of BAC. Generally, when we write or if something is given like this, AD is the angle bisector, and there is no other angle that it can bisect. There is no angle at D, right? So the only angle that it has is A. So it is implied that it will be angle BAC. Siddesh,
Sir,
go ahead.
sir, if you have proved that this is a isosceles triangle by your proof, but if it is a isosceles triangle, shouldn't the angle bisector be the median of the triangle? And if it is the median, shouldn't E and D be the same points?
How do you know that?
Sir, because you are telling that it's a isosceles triangle.
No. So how do you know about all these things in isosceles triangle?
Sir, what
Whatever
am
you are
unable-
saying, whatever
Yes,
you
sir.
are saying in an isosceles triangle shouldn't be like this, should it not be
Sir,
like this?
Sir, I can tell the angle bisector theorem, sir. AB by AC should be
So
equal to BD by DC.
what you are saying, like Gayatri, is you are taking something from what you have already learnt, right? And then you are trying to plug it here, right? So you are saying by our prior knowledge that contradicts to this particular thing.
Yes,
Is that
sir.
correct?
Yes, sir.
I agree to that point. I am not in disagreement to that. I am saying I have written something. Shouldn't there be some mistake in my logical process? See, my process is so logical, right? Don't you see that? Do you see any flaw in statement A? First statement, you will soon know. First statement is correct. Second statement, correct. Third one, correct. Fourth, correct. Fifth, correct. Sixth,
You are
correct.
asking me not to compare this with the knowledge I know,
What
but find
do
the
we mean
flaw in
by
the proof you have given.
deduction? Deduction is from statement 1, statement 2, statement 3. We write, so statement this one follows from the first statement. Then
Yes, sir.
this also follows from this. This also follows. So for every statement, I have a reason.
Yes, sir.
And this is how logic works. So if you agree with each and every statement that I have written, then you cannot run away from the logical conclusion. If you
Understood.
don't accept this particular thing, then you need to point out what is the problem in the sequence that I have written. That is what I'm
Understood.
asking for. Okay.
Okay.
I also agree that every triangle is not isosceles. But think about it like a student asking, I've written this proof. Can you tell me where am I going wrong?
Yes, sir. I understood, sir.
So,
I will tell.
can you show the construction part?
Surya and then Vihan.
Sir, as someone said earlier, I think O will always be on the exterior of the triangle.
Maybe it is, maybe it is not. Right?
No, sir, always I think. Because there is a property like
Maybe that happens
angular
in
bisector.
Tirunelveli, Surya, not in Bombay. No.
Sir.
Okay, I'll come to you. Vihan.
Sir, it lies on the circumference of the
Lies on the circumference of the
circumcircle.
I see. Okay. Vihan.
So I have a doubt. How did you get that triangle PAO is congruent to QAO?
You see this angle is congruent to this angle. These two are right angles. So obviously the third angle should be congruent to the third angle. This is a common side. You can use ASA or we also call AAS, angle side.
Okay.
Okay. Anahita.
Yes, sir. So last step you have written that AB is equal to AC, like therefore it is isosceles, and that you have derived from AP is congruent to AQ and PB is congruent to QC, and therefore we
Correct.
can say that AB is equal to AC.
Yes.
So we are not concluding that PB. So sir, by congruence we mean they are equal or what? We don't mean that, right?
So congruence means they are equal in all respects.
Okay. So their addition will also be equal. That is what you mean by saying that.
Of course. Yes. Yes. So if A equals B and C equals D, then A plus C is equal to B plus D. We cannot run away from this.
Okay, right. Okay,
Okay.
right. Yes. Okay.
Maybe
Sir,
I'll
I have
ask.
a doubt, sir.
Yes, doubt. Go ahead.
Sir, is BQ and PC aligned?
PQ and PC. Yes.
Sir, then isn't
Oh no.
OP
I'm not saying anything of that sort. I'm not saying anything of that sort. No.
Okay, sir.
Yeah. Parul.
Sir, another doubt. In the beginning only, you wrote consider a triangle ABC where AD is the angular bisector. And what is that and B dash D slash? I mean, not slash.
B dash D dash C means B, D and C are collinear and D lies between B and C.
Okay.
It means it is not something like B, D, C. D is not lying outside. D lies on BC and between B and C. That's what it means.
Okay.
Yes.
So we just proved that every triangle is isosceles. But like, how can it be?
Correct. That's what I'm saying. I don't know whether you were there 2 minutes earlier when I said every statement that I have written. See, how do we analyze if a proof is right or not? We don't bring in our notion. We don't bring in what the world believes or what the world's best mathematician has said. We go by logic. So we see, is there anything wrong in the first statement? Yes.
No.
Second statement, third statement. I ask you to go by statement by statement.
No, can you hear me now?
I can.
Yeah, it's right, sir, statement.
All the statements are right, right? So if the statements are right and they are logically coherent, then we have to accept what the last statement says. It's as simple as that. But if we don't want to accept it, then we will have to say what is wrong in the statements. That's the question. Purvi.
Okay, thank you.
Yes, I think I found out a mistake in the thing. In the proof. So in the statement number 1 that we have written, OP is similar to OQ. So
congruent. Triangle PAO
no,
is
they're
congruent to
similar, right? Oh, right.
It's congruent.
Deepti.
Okay, no, I think
in our cases, even P accept as isosceles, so we can 2 and 4 imply that and
I think my internet is a bit low. I
No,
lost.
sir.
Sir,
No, sir. We are all
No,
not able
sir.
to hear her, sir.
Okay. It's not just me.
Sir, I have another doubt, sir.
Yes.
Sir, how can you say that OP is equal to OQ, sir?
OP is equal to OQ because triangle PAO is congruent to triangle QAO.
No, sir. Means while you are saying this is they are congruent, you have to give like angle, side. No, sir. Which angles are we? Just so that I understand if something is
I
wrong.
marked it. I marked it here. Angle. Okay. Angle
Okay.
PAO.
Common side. Understood.
All right. So,
Sir, I have
break.
one bug or whatever.
So I have
Parul.
a like a
Parul and then Vihan.
suggestion.
Parul and Vihan. Yes, Parul.
Sir, so we know that in an isosceles triangle, yeah, so two sides are equal, and the median between these two adjacent sides will not only bisect the angle on the top, that is the angle in between these two equal and adjacent sides, but it will also bisect the line segment on the bottom, correct?
Okay, 1 second. Can somebody guess or answer to Parul what you think my answer is going to be? My reply is
I
going to be.
told the same
Sir,
thing.
that
We have to
same
find fault.
it's a
What
conclusion
is
from
the
your
Dikshant,
previous knowledge.
Dikshant, just reply to Parul, and Parul, let
Sir,
me know if
you told that it is an observation which can be true in like some isosceles triangles, but here we have to find the mistake and not what should be here.
Okay, somebody else. Good, Dikshant. Anyone else would like to answer?
Can I, sir? Can I?
Who is this?
Kavi.
Kavi. Yes,
So, but
Kavi.
all triangles won't have the angular bisector.
Hey, I'm asking you a question. You are replying something else. I'm saying Parul just made a statement. What do you think is my answer to Parul going to be? Because I've already said this 2-3 times. So I just want
Sir,
somebody to. Who is that?
Samir.
Yes, Samir.
Sir, it's a conclusion from our previous knowledge that the perpendicular bisector of the line coincides with the median. So we cannot just assume it from in this proof.
Okay, yes, sir.
Right.
Sir, but
And
it is proven also.
So you guys are saying what is already proved in another theorem. I will repeat this, and I want everybody to understand this clearly. See, when you say something like A equals B and B equals C, then you have to conclude that A equals C based on these. You cannot bring in, oh, something else is true. Then you will say, what is wrong in this? Is this correct? Yes. Is this correct? So this is the logical conclusion that we draw. You cannot run away from this. So my point, Parul and others who are still trying to bring in the previous knowledge of isosceles triangle and all those things, while I agree that they are correct, what I expect you to find is a flaw in the logical argument that I have given. If you agree that each of these statements are correct, you say that yes, this is correct, this is correct, this is correct, then this is the logical conclusion that we arrive at. You don't want to accept this, you find a flaw in this.
Okay,
that
sir.
Is how logic. Okay, Parul,
So
is that
I
clear?
might have found a flaw.
Yes, we have.
Yeah, sir, is just a question before I start. Is PC and BQ on like is B and Q a collinear line? Like
You mean
BQ
B dash
straight
O
line?
dash Q and
Yeah.
P dash O dash C? No, nothing
Are
of that
they
sort is given.
no, like are they a straight line?
I don't know.
Sir, you can't say that, right? Because you
I
just
can
proved
say
congruence.
I don't know because I haven't proved it. They may be, they may not be. Anyways, I'm not using that. Even if it is true, I'm not using it, right? Have I used it anywhere? Yeah. And it's like you're asking, is PB congruent to DC? I don't know. Is AF congruent to ED? I don't know.
Okay.
Yeah.
Sir.
Anahita, last. Yes.
Yes, so just a doubt. The construction is a part of our assumption or what?
Yes.
Okay, so okay, nothing can be done in that. Got it.
Part it's so whatever I have written is part of the proof. Okay. This entire thing is my proof does not start from here. So this is my solution. Okay. In that solution, I'm giving you certain arguments and then I'm writing a construction. Then I'm saying this is my proof. So this entire thing is my, so you may want to evaluate the entire thing and not just from the proof part. Right?
Got it.
Shall we move on to the next topic? And we can take this in the doubts clearing.
Sir, but what was the mistake here?
Well, you know, I would
I
want you
think
to
I have a
lose some
last-
sleep.
Sir, can I
last
try
try
one
for the
last time?
Sir, just a doubt again, sir.
Yes.
Sir, while we are means disproving a proof, if I can tell, can't we just rule out that one construction does not match the thing which we are trying to prove itself?
How will you do that? I mean, I'll be happy
Sir,
to accept. Just give me
no,
the
sir.
argument.
I mean that you're trying to prove that this triangle is an isosceles triangle.
Mm-hmm.
The basic thing that the perpendicular of this triangle of which you're trying to prove is isosceles originates from a point which is not a, means you are telling that I'm taking it from prior knowledge, but not here, but somewhere else. Can't we use it to disprove it?
So again, I'll repeat my question. Tell
No.
me the step over here where I have.
Yes, sir. Yes, sir. I'm understanding
cheated.
that there would be some mistake here. Just if to disprove something else, or is it consensus that I cannot use anything like that and I have to find the mistake in the set?
Yes, you have to find the mistake in this set of logical sequence that I have given.
Okay, sir.
Okay. Anyone wants to go one final go, and then we will.
Doubt, sir. So
Can you give 2 minutes to think?
Kavi,
Sir,
doubt.
I
Yes,
think I
Kavi.
have a
1 second, Kavi, and then yes, Kavi.
How do you know that AD and EF would intersect at O?
They will intersect somewhere.
One day AD would bisect. One day AD pass through E and not even intersect. Is there any possibility?
I'll repeat my sentence. Find mistake in the flow. Urvi,
You can't use prior knowledge in this.
find the mistake in my flow. Urvi.
yeah. So what I think is actually causing a problem is that PC and BQ are perpendicular. Perpendiculars dropped on the sides, right?
No. OP and OQ are perpendiculars. I never said CP and BQ.
Okay.
See, my statements are very clear. Okay. So I am that lawyer who's arguing for the world's most wanted terrorist. And you don't want that fellow to go unpunished. So that's where we are.
Sir,
Yes,
how do
Kavin.
you say
Exact analogy, sir.
equal to angle C?
Kavin, say that again.
How do you say that angle B is equal to angle C in the RHS proved by RHS?
I don't care about that. I'm saying an isosceles triangle will have two sides congruent. I proved AB congruent to AC.
No. In RHS, in the using 1 and 2, we proved that triangle POB is congruent to triangle QOC. If you say like this, P should be equal, angle P should be equal to Q, angle O should be equal to O, and angle B should be equal to C, right?
That is a logical conclusion. Yes.
And how will B equal to C? How are you concluding that B is equal to C?
That is corresponding sides of congruent triangles. I first prove the triangles are congruent, and then you can say, okay, the logical conclusion is these two are congruent.
By what? Corresponding sides of congruent
corresponding angles of congruent triangles, or corresponding parts of congruent triangles. Have you learned congruence?
Yeah.
Yes.
Right. So there is right angle, there is hypotenuse, and there is side.
Sir, I have found a way to make
Sir,
it.
I'm Arham.
Yes, Arham.
Sir, I want to say that we have not used proof by contradiction anywhere here. Sir, we have just proved that ABC is isosceles, but that doesn't mean that every triangle is isosceles.
No. Is ABC a general triangle that I have taken? Arham?
Sir, I think so.
Yes, right? And I have proved ABC is isosceles.
Yes.
Which means a general triangle is isosceles. Right?
Sir, but where have we used proof by contradiction here?
I haven't used proof by contradiction. You have a problem with that? I haven't used. Oh, because this is an exercise immediately after the topic of proof by exercise 3.1 has to be based on what was covered just before that, like a textbook. You expect that it to be? No.
Sir, what if we shift that, if we draw a parallel line to EF that passes through A? So it will be a perpendicular passing through A.
I will say the same thing. Read through what I have written. Find a problem with one statement.
Sir, another doubt, sir.
Sir, there is problem in construction, sir.
Where?
Sir, EF should pass through A.
EF should pass through A.
No, not necessarily.
That's what I said because of the median, but sir said you
Hey,
can't.
you
Sir, we
have a
can prove
triangle
it
like this.
also.
Wait,
Sir,
you have a triangle like this, okay? And then you are drawing the perpendicular bisector here, okay? And you are saying that it has to pass through this, has to pass through A.
if it is isosceles.
A day.
Not
Dikshant,
considering that.
I wish you are in my class and I could give you a tight slap. This is the 10th time I'm telling you, go through this. Don't bring in what your godfather told you that, oh, in an isosceles triangle, what is going to happen? Tell me, if anybody says one more statement that I know this about isosceles triangle, I'm going to kick them out of this room. Yes.
Sir,
you better
did
be
not
saying
prove
something
that-
good, Siddesh.
You did not prove that EF intersects AD.
I did not prove it. That's my construction, man. EF meets AD
Sir,
at some.
your construction is EF is perpendicular to BC, but you cannot be sure it will always intersect AD, sir. I can
Oh,
always
they can be
construct-
parallel. They can
No,
be
sir,
parallel.
Sir, they cannot. I am telling you have not proved they intersect inside the triangle.
Then where will they intersect?
Sir, they can intersect outside also, sir. But
Outside.
your whole proof depends on it intersects inside the triangle. Sir, I can draw a triangle where the angle bisector does not intersect the perpendicular bisector inside the triangle.
Yes, sir, it will be always outside the triangle.
Sir, it is a fair point.
Not always outside, it can be inside, but not in every case. We have to
even I was.
Oh, when it is inside, then it will be isosceles.
Sir, I'm not telling that and all, sir.
When
I'm
it is
telling
inside, then it is isosceles. You have to agree that.
Sir, I don't know, sir. I'm just telling
You just said it. It is not always outside. Sometimes it can be inside. That means when it is inside, those triangles are isosceles.
Sir, but in this proof, you have to prove that in all arbitrary triangles, it intersects inside a triangle. If you prove it, sir, your proof is correct.
Okay, so
Sir, I think just a second.
Yes.
But if we prove the same for an isosceles triangle, I think it will result not being an isosceles triangle.
Kavin,
no, we cannot say
you
like
stay in Chennai, right? I'm going to come there and take care of you, okay? Now, coming to Siddesh. Siddesh, okay, so everybody, what Siddesh said, something similar to that was, and in fact, Surya also agreed to that, something similar to that was told by a couple of them earlier, that O will not lie inside the triangle. O will not lie inside the triangle. But that was a statement. O will not lie inside the triangle. But what we are missing, okay, or what they missed, or what others missed, is that this construction is based. So this construction as an EF is the perpendicular bisector of BC and meets AD at O. This is fine, until here it is fine. But what I have assumed is that O is inside the triangle. That is my assumption. Now here, if we do this, there can be three cases. O is inside, O is on the triangle, O is outside the triangle.
Sir, can I confirm one thing?
Just 1 second, let me complete this. So when we are saying this is meeting O, I also have to say where O is inside the triangle, which I did not say tactfully. So here, let me just write this, where O lies inside triangle ABC, then somebody can definitely question, how do you know this? Right? What I have drawn, how do you know this? On what basis are you making this statement? So this is purely my assumption that I have made. So I'm saying, let us assume that this is true. On what basis? Right? There is no basis for this particular statement. For every other statement, there is a reason, but for this statement there is no reason, and that is precisely, and it is not, the proof is not wrong because there is no reason. The proof is wrong because this is not true. O will definitely lie outside the triangle. Now, if those who said O lies outside the triangle, not inside, I already said that. Why didn't you accept it when I said? The reason I did not accept it is because what I was expecting is you will tell this is an assumption that you have made and it is not necessarily true, or on what basis are you coming up with this particular assumption? Okay. On
now
what
I can
basis?
sleep peacefully at night.
Yes, you can sleep peacefully at night. Is everybody okay with this? You can respond with a
Actually,
reaction.
only I have
And
one.
Say the
Can
same
you
thing.
speak for once again? I just want to read it once.
yeah, I mean the proof is there in the Google Classroom. So
No, like the mistake.
It's me, sir. Sir, after step 4, in step 4 you prove that PB is congruent to QC, and step 2 you prove that AP is congruent to AQ. How did you conclude that AB is equal to AC? It should be congruent, right?
where?
Sir, last statement. From 2 and 4.
Yeah, congruent. Generally,
So,
I mean,
sir, in cases
one
where
second, sir. So when we generally say AB equals AC, what we mean is length of AB is equal to length of AC. It also means that AB congruent to AC. About 40 years ago, this was not 40, I'll tell you, 19. About 22, 24, about 25 years ago, this was the way of writing and not this. And I'm saying this because the notation changed when we were in 10th standard, 9th standard or something like that. So earlier they were only writing like this, but then they said this is equal to this as well as this. Let's not worry about it. So yeah. Vihan, question. If your question has been answered, please, lower your hand so that I know how many hands. Yeah, Vihan.
So I had a speaker issue, so I couldn't hear anyone for the past 5 minutes. Can you please tell what was the mistake again?
The mistake was that I made a fundamental assumption that O lies inside the triangle ABC, and I have not given any reason why it is so.
Okay, so there are two cases where O lies inside ABC, it's always isosceles. Where O does not lie inside ABC, then it's not isosceles.
So the question is, can O lie inside ABC at all?
In some cases.
Are you understanding, Vihan?
Yeah.
Yeah. So can O lie inside ABC at all? So that is a fundamental question that we need to ask.
Okay.
Okay, which I wrote just as a statement. I did not mention on what basis I'm saying it means where does O come into the inside the triangle. All right.
Actually, I was
Deekshant,
keep on checking the congruence conditions, checking for a
What if,
mistake, and it came
I
in the
know, I
first
know, I know.
part.
in the cases where O lies inside, then it can be isosceles?
The question is, can O ever lie inside the triangle? That is the question.
Yes, it can lie in some
Yes,
cases.
sir, it can.
It can overlap on E, sir, not on.
Construct it. It can see O. It will be EF and AD are the same lines. That can happen. Otherwise,
that
O will always lie.
In the case
Otherwise,
of
O will always lie outside the triangle, not inside the triangle. Okay. Anahita.
but we will need to prove it that otherwise it will always lie outside, because otherwise we cannot say that this is the exact mistake in the proof.
Fine. So okay.
I
So
suspected that this might be
the
true,
flaw
but
the flaw in this proof, once again, Urvi, is that I have made, okay, so what you are saying is you have made a baseless statement and there is no reason in this particular thing. Now we need to show that O can never lie inside the triangle ABC. That's what you are saying, right?
yeah,
We need to prove that. Fine. So that can be a different proof that we can think and argue why O can never lie inside triangle ABC, and then we can complete it.
yeah.
Okay. My thing was, which is the part which is not logically deductive, or there is no base to that statement, and that was this statement.
Okay, I thought we had to like correct the proof or something. So like you have
But
to
this
prove
thing
as
you
well.
missed. This thing you missed, right? That this was a
No, I
baseless
was going
statement.
to prove that. I was going to prove that O always lies outside.
Right. So
That's what I was trying to do.
this is the bug in the proof. This thing is the bug in the.
Yeah,
Okay.
I suspected that, but then I thought we had to prove it, so I went on that path.
Ah, okay, okay. I see what you're saying. Okay. All right. So let's
Sir,
move
so
ahead.
finally, the answer is because there's no proof why O lies inside ABC.
No,
Is the thought.
not there is no proof. The problem is I have made an assumption that is never possible. And of course, this like Urvi said, we need to prove that. Okay, but we are not getting into that right now. But the problem is you make an assumption of something that is not true, and this is something that is not true. If you make such an assumption of something that is not true, then you will get something that is fundamentally flawed.
Sir, why is it not true, sir? Because O is like
So that is
pure.
a different proof altogether. We can do that, or we can go into proof by contrapositive, which I want to get you guys to. Okay. Anahita, Siddesh, if you have questions, I'll take. Otherwise, we'll move ahead. Anahita.
Yes, sir. I have a question that necessarily in the domino effect, what we did was that we assumed K to be true. That was also like we did not have any proper proof
It was
for that.
induction.
So we can assume even that here, and therefore
No.
this
So
proof
when in induction, we are saying if K is true, assume that K is true. We are not saying that K will always be true. We are saying assume K is true. And if K is true, we show that K plus 1 is true. So we are showing a cause and effect relationship. Until that also, there is no certainty that K is true. Okay. We are saying if K is true, it's like if it rains, the ground will be wet. That does not mean that it has rained. We are saying what will be the logical consequence of that. And then we are showing the base case and saying, look, the base case has happened. And because of this cause and effect, K has to fall. So using that base case and this cause and effect, we are showing that our induction hypothesis was true.
So here we are not considering, we are just completely considering it to be true. We are not assuming it.
Yes.
Okay.
And we are taking it for granted.
Yeah, without any got it.
Yeah. Siddesh?
Sir, if you wanted to prove the state solution fully, you had to prove that O should lie inside the triangle for all arbitrary triangles, right?
Yeah, that's what I'm saying. Yeah.
Yes, sir. And if I want to disprove, I just have to tell that you haven't provided the proof, or that I have to prove that it always leads outside.
So you'll have to say that this statement
does not have any proof, that's
baseless.
all.
Yeah.
Yes, sir.
This statement is baseless.
Okay, sir. Thank you.
All right. Yes, I'll continue once I have the videos on. If you have an internet connectivity issue, send me a message. Otherwise, I'll expect your videos to be on. Shlok, are you there? Shlok here? What about others? Yash. Shlok, are you here? Okay, I can see some messages. Just 1 second. Okay. All right. So those who have messaged me, that is fine. I understand. Right. Sriram, just put Shlok in the waiting room. Not receiving any response from him. All right. We'll continue. Sriram, can you do that for me?
Yeah.
All right. Kavi, I'll take questions later on. We'll go to this topic called implication. Kavi, I'll take it later on.
Not questions, sir. I'm saying that you haven't posted root to irrational proof.
That is fine. I'll do that. Yesterday I was completely tied up. I will do that.
Okay.
So implication.
Yes, starting proofs by contrapositive, no?
Yes, we are doing that. For that, we need to do implication. That is what I'm going. Okay. Can I start? Okay. So implication. Implication is generally denoted like this, and we read this as P implies Q. Now, what this means in simple words is if P is true, then Q is true. In simple words, okay, in simple words. If I say there is a statement P, that means it rains. And statement Q, the ground is wet, right? We know that if it rains, that is true, okay? That means if it rains, then the ground will be wet. So don't consider there is a shade on the ground, or maybe there are trees on the ground, or maybe it drizzled. No, now I'm just taking a open ground, and if it rains there, then the ground has to be wet. Okay. So if this is true, then this is true. Right. So this is what implication means. Implies means from this, by looking at this, we can conclude this is true. Now we write this for saying negation of P. This is, read this as negation of P. Negation of P is, in simple words, the opposite of P. So it rains, the opposite of that will be it does not rain or it did not rain. Negation of Q, negation of Q. Take down notes wherever you want to. The negation of Q is the ground is not wet. Okay, the ground is not wet. Okay, that is the negation of Q. All right. So negation of P is it does not rain. Negation of Q, the ground is not wet. So you cannot take the opposite of ground as sky. You cannot do all those things. Okay. The ground is not wet. The opposite of that will be the ground is wet. Opposite of that will be ground is not wet. So if I have to prove, if I have to prove that if it rains, the ground will be wet. Suppose I need to prove this statement. Okay. Suppose I need to prove this statement. Then what I can also do is I can show that negation of Q implies negation of P. That means if you see that the ground is not wet, you can definitely conclude that it did not rain. Right? That's what we do, right? In the monsoon, we look outside the window, you see, oh, the ground is not wet. We know that it has not rained. So that's a logical conclusion, right? So what we are saying is, if you want to prove this, it is sufficient that you prove this. Okay. So if you are proving this to prove this, then we call it proof by contrapositive. Okay. Let me give you an example to demonstrate.
So can you wait for 1 minute, please? I want to note all of that.
Yeah. Can you take a screenshot and write it down later?
Okay, 1 minute. Yes, I do.
Guruvi, question?
Yeah, actually in the first statement, if you could scroll up. Yes. Yeah, in the first statement we have said it, if P is true, then Q is true. So that doesn't mean that when Q is true, P has to be always true, right?
Exactly.
Because we haven't said if and
Yes.
only if P is true. So
yes.
So now there is one problem in this, that if P is true, then Q is true, and we do not know if Q is true, then P is true or not. So if we prove the second statement, which is negation of Q implies negation of P, that doesn't necessarily mean that P implies Q, is what I think, because
Okay.
yeah. So the
Okay.
ground is not
Siddesh,
wet,
wait.
implies it doesn't rain.
Yeah. So if
Doesn't
you see
mean
the
that
if you see that the ground is not wet, right? Ground is not wet. Now you may say, oh, it rained and the ground is dry now. You're looking at after a long time. No, that is not what we are talking. You look outside, you see the ground is not wet. The ground is dry. Okay. What is the conclusion that you will make, Urvi?
that it didn't rain.
That's what I'm saying. Because rain, the logical consequence of rain is the ground being wet. So if the ground is not wet, then definitely it didn't rain. Okay. Now to remove this question that Urvi has, there is something called as a truth table. Okay, I'll be able to just touch upon this because I want to demonstrate one or two problems using proof by contrapositive, and I don't expect you guys to get 100% of it, but at least if you know that there exists a proof technique like this, maybe you will be able to whenever you see problems like that. So this is P, this is Q, two statements. One possibility is P is true and Q is true. Another possibility is P is true but Q is not true. And P is false, Q is true. P is false, Q is false. Two statements. Forget about what those statements are. Okay, what those statements are. Then there are four possibilities. Okay. Now let us bring in P means it rains. Q means the ground is wet. These are the two statements. Now, when we say negation of Q, negation of P, it would mean, okay, let me write negation of P later. Now, let us check P implies Q. Okay, P implies Q. So, if it rains, then the ground is wet, is a true statement, and no question about that. So, if both of them are true, then P implies Q is true. If both of them are false, then P implies Q is
True.
true. Very good. True, because if it did not rain, the ground will not be wet. It is true.
What if we put water on it on our own?
If it if it did not rain, okay. If it did not rain, okay. So that is the next case that we are coming to. Okay, it did not rain. Can the ground still be wet? Yes, it can be wet.
Yes.
Yes. Okay. So can both these statements be, so this is false and this is false. Is that possible? Yes, that is possible. That is where we are putting it true. It did not rain and the ground is still wet. Yes, that is also possible. So we put it true. It rained and the ground is not wet. No. This is not possible. So we put a false there. Okay, this is not possible.
So this case won't work, right? That's what I'm trying to say.
Yeah, this thing will I'm completing, and maybe that doubt will be clear for me. Okay. Now what is negation P? Negation P is if P is true, negation P is false. So this will be false and this is true and this is true. Negation Q is when Q is true, negation Q is false. When Q is false, negation Q is true. False. True. Now I want to check negation Q implies negation P. Okay. So you can swap these two and you can think of, in this order. You're saying it did not rain.
The first is true.
The ground is wet. Is possible. It. Sorry. That is not the first case. That is the last case actually. It did not rain because that is the ground is not wet. Sorry, the ground is not wet. Let me just write it down. The ground is not wet.
Sir, that is the true statement.
And it did not rain. So that is the last statement. The ground is not wet and it did not rain. Okay. So I'm saying not negation P implies negation Q. It is the other way around that I'm saying. Okay. So if you want, you can write it in this way. Negation P will be F, F, T, T. Okay. This I'm just writing on this side. Okay. So negation, and this is this. It did not rain. So the ground is not wet and it did not rain. Yes, that is possible. The ground is not wet. That means the ground is wet. This is it did not rain. Because it's false of not raining. So that means it rained. That is also true. Now, if you take it, the ground is not.
Sir, it should be false, right? Because Q implies B. If the ground is wet, it doesn't necessarily mean that it has rained.
It doesn't necessarily mean correct, but is it possible that it rains? So this P implies Q. So we are saying whenever it is possible, we are putting it true. It's not meaning that it is always true. See, there is a possibility. Now, when the ground, is not wet, that means the ground is wet. The question is, can we have negation P? Negation P is it did not rain.
Yes.
So can the ground be wet? Even if it did not rain, yes, it is possible. Somebody can just put a bucket of water. So this is also true. Now we come to the last part.
No, sir, not
The
Not
ground is
False.
not
It
wet and it did not rain. That means it rained. So we are saying it rained, but the ground is not wet. That is not true. That is false. I know that to accept this at the first go is not easy. And even if you think you have understood it 100%, there can be a lot of examples where the ground will still shake. Okay. So I'm just putting this as a just like a teaser so that I can get into proof by contrapositive to show this. And because Urvi raised that question, how does P imply Q necessarily mean that negation Q implies negation P? So we say when the truth values match exactly as it is, then we say that these two are logically equivalent. Okay, they are logically equivalent.
Okay.
If you take
So
Q implies P, if you take Q implies P, and you take these two statements, then you will see that this will be true, this will be true, this will be false, and this will be true. Unfortunately, we don't have time to get into this deeply.
sir, I got
but
it. Yeah.
yeah, so these two are not logically equivalent because here the values change. So we cannot say that.
So
This
for
is where
each
Urvi was
case,
saying
it is
this.
the same thing. So that's why we can conclude that if this is true, then this also be true because they're logically the same thing.
Yes,
So
yes.
Sir,
yeah,
if
got it.
Q implies P, is it necessary to be negation of P implies Q?
Q implies P
Then
will
negation of
always be negation of P implies negation of Q.
Okay.
This means they are logically equivalent. Okay. All right. So let us get into the problem. Let me take an example. Let's say I don't know, maybe some of you know this, that all primes greater than 3 can be expressed
6n plus 1 minus 1.
as 6x plus or minus 1. 6x plus 1 or 6x minus 1. Okay. Let us say that we want to prove this, and we want to prove this using contrapositive. Okay. Which means we want to show that P implies Q, and how we are going to do that is by showing negation Q implies negation P. Okay, this is our goal. Our goal is to show P implies Q. What we are going to do is show negation Q implies negation P. What is our statement? Our statement is this. P. P is, can somebody tell what is P here?
All primes greater than 3.
All primes, or maybe primes greater than 3, doesn't really matter. Okay.
If primes are greater
Q
than
is 6x minus or
It can be
plus 1.
expressed as 6x plus or minus
6x minus 1, or can be expressed as 6x minus 1 plus or minus 1. Okay. Now what we are saying is if P is true, then Q is true. This is to prove. We need to prove if P is true, then Q is always true. This is our goal. Okay. This is our goal. Solution.
So we can prove that.
One second. We will prove this by contrapositive. We will prove this. See, all these statements give a clear indication to the reader that this is what is going to follow. We will prove this by contrapositive. That is to show that negation Q implies negation P. That is, what is negation Q?
It cannot be expressed as 6x
As
plus or
6x
minus 1.
minus or plus.
Purvi?
Yeah, actually, I think I have a way to prove this thing using contrapositive.
Okay, wait.
Uh,
Just want to take questions. Anahita, question?
No, sir, wanted to answer that Q
Okay,
negative.
Kavin, question?
I wanted to answer.
Samyak, question?
Sir, here X should be a whole number, right? Otherwise, it's obvious.
Yes. So we can say this is numbers of the form. Okay, numbers of the form 6x plus or minus 1. Okay. So to show that negation, so what we are saying now is, what will be negation of Q?
Numbers
the
not of
the form
not
that
of
are
Numbers not of the form 6x plus or minus 1 implies that
numbers of the form 6x plus or minus 2 plus or minus 3 plus or minus.
Wait. No.
Are
Numbers
not
not of
prime greater than.
yes implies they are not primes greater than 3. Look at it carefully. It does not mean that they are primes less than 3 or less than or equal to 3. They are not, composites greater than 3. No, that is not the negation of that statement. The negation is they are not primes that are greater than 3. Okay. This is our goal now. Is everybody clear? If you have a doubt in this, please do
Sir, we
raise
can
hand.
prove it by factorization.
1 second, Ari. I'm asking. Doubt hai to bolo. Doubt nahi.
Sir, can you please tell negation of Q once again?
Yes. What is Q? Q says that numbers of the form 6x plus or minus 1. So the negation will be numbers that are not of the form 6x plus or minus 1.
Okay.
Okay.
Sir, negation of P should be primes less than 3, right?
No, so that is what. So to take negation, no, we'll have to get some practice on it. It will always be like this. If P is true, negation of P is always false. And if P is false, negation of P is always true. So if you have a statement P and you think, oh, this might be a negation, this might be a negation, this might be a negation, and you keep going through those negations, then you will have to see if P is true, is this negation also true? If P is false, is this if P is true, then is negation false? P is false, then is the negation true? You'll have to check that every time. And when you do that, you will see that this is the only thing that works. Okay. All right.
So we have to check the negation and
yes. So again, these topics are usually covered after doing Boolean algebra. Okay. So that is why I'm skipping that part a lot, because we want to focus on proofs. So these questions that you are having are quite natural questions, but you will get there eventually. I just want to show you the proof technique. Neil, question?
Yes, sir. Sir, above you had written goal is to show P implies Q, but here you are telling goal is to show. Sir, is that not what we need to do to show that P is implies Q?
Right. So we are not done with the proof yet. We are saying our goal is to show P implies Q, but what we are going to do is to show that negation P implies negation Q.
Negation Q implies negation P, right?
Sorry, negation Q implies negation P.
Okay.
That is what we are going to show. So we are saying we are going to do this by proof by contrapositive. And what is our goal? The goal is this, and this is what we are going to establish. Sriya, question?
Sir, the goal P implies Q, it's already given, right?
Sorry.
Sir, it's already given that P implies Q, right?
No, that is our goal. That means we need to prove it. To prove.
Sir, but it's already written. Okay.
Okay, that's the problem that we are trying to prove. All right. Urvi, you wanted to say something earlier? Yes.
No, it just I want to answer that.
Yes. Go ahead.
Even I want to answer.
Do a raise hand. Those of you who want to answer, I'll call out names. Starting Urvi. Yes, Urvi.
Yeah, I was thinking what we could do is we could say that numbers not of the form 6x plus 1 plus or minus 1, we could take it with respect to the remainder of with respect to the remainder of 3 when divided by 3. So what we could do is 6x plus or minus 1 is going to result in a remainder of 1 or 2 of 3, right? And so numbers not of the form with remainder 1 or 2 of 3, which means that they are of the form 0 remainder of 3, because there is no other
Okay.
option for 3. And that means the remainder of 0 when divided by 3, which means that it's not a prime greater than 3, because except 3 there are no primes that are divisible by 3. That's exactly what a prime is.
But I have another way.
One second, Dikshant. Urvi, I have a problem over here, or at least I am posing to have a problem here. Okay. Maybe what I'm saying is correct, or maybe that is bogus. So that is up to you to find out. I take a number. Let's say 118. Okay.
Yeah.
My question is it of the form 6x plus or minus 1?
No.
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 Right. Okay. Does that imply that they are not primes?
Yes, I mean it is not a prime.
It is not a prime. Okay. What if I take 121? Is it of the form 6x plus or minus 1?
Yes.
I think so.
It
Yeah.
is 6x
Yeah.
plus 1, right? 6x
Yeah,
plus
6x
1.
plus 1. Yeah, yeah.
Right. Now numbers not of the form. So that means we cannot take this number because we are talking about numbers not of the form.
Yeah, but this is implying that they are not prime.
This is implying that they are prime.
The Q does not imply P. P
Can I-
implies Q.
Sir, can I?
Okay, one second. So, Urvi, when you are saying you divide by 3 and the remainder 0 or 1, we are not talking about division by remainders when we divide by 3, no? Because the problem is talking about remainders when we divide by 6. And if that remainder is 1 or negative 1, that is 2.
Okay, so we can also do it.
You see what is the problem I have with your argument?
Yeah, I got the problem. But I think it can be solved because we can say that 6x plus, we could take it this time with respect to 6, because it would be more appropriate with respect to 6 is what I think. So what we'll do is, if it's not of the form 6x plus or minus 1, which means it's of the form 6x plus 2, 6x plus 3, 6x plus 4, or 6x plus 5. But 6x plus 5
No,
is
5 is
basically
not
minus
there.
1. Yeah, 5 is not there because it's just minus
And
1.
6x itself.
And 6x itself.
Yeah.
Right?
So like
So
all of
these are the numbers. Just a moment. Everybody, these are the numbers that are not of the form 6x plus or minus 1. It has to be one of these.
Yeah.
Okay,
And
Dikshant, continue.
Now we can factorize each of it. 6x plus 2 is basically 2 times 3x plus 1. So it's not a prime as it's divisible by 2. then it is 3 times x, so 2x plus 1 divisible by 3.
Multiple of 3.
Then it is 2 times, no, yes, 2 times 3x plus 2. Even number, and it is also even.
Right? So therefore, these are not primes.
Sir, could you
And
please go up once to the question?
yes.
Sir,
So I'll take questions now. Those who had answers
thank
can
you.
lower your hand. Just raise your hand if you have a question. Anahita?
yes, sir. So we just did not consider 5 as it will be a prime, right? That's the reason. 6x
Uh,
or what's the exact reason?
6x minus 1 is 5, right?
6x minus
Yeah.
1 would be 6x plus 5. Like it's equivalent.
so I think Anahita is asking something else. She's saying, why did we not consider 5? Is that correct, Anahita?
Yeah. Like why did
Because we are not considering numbers of the form 6x plus or minus 1. So 5 we are not considering.
right, yeah, sorry. Yeah, sorry.
Arham, question?
Sir, I'm not understanding what are we doing.
Okay, no problem. Let me, okay, Arham, let's talk, okay? Any number can be written as 6x, 6x plus 1, 6x plus 2, 6x plus 3, 6x plus 4, or 6x plus 5. Do you agree?
Yes, sir.
Yes. If you have a number of the form 6x, it is not prime.
Yes, sir.
If you have 6x plus 2, 6x plus 4, they are not primes.
Yes, sir.
You have 6x plus 3, then also they are not primes. So the only place where primes can exist are these two compartments.
Sir, why 6x plus 5?
Okay. 6x plus 5 is the same
Because
as
it does
6x
not have
minus
any
1.
common factor with any of the other terms of 6x. Like 6x plus 2, you can take 2 common, and generally it is not a prime, right? And we are taking numbers
I
greater
think
than
Arham
3.
is asking a slightly different question. Arham, these boxes does not mean that they will always be prime. No. It
Sir,
does
it
not
doesn't
mean that.
Like, what are the possible forms? Like, where can we
Can I
obtain
just
a
answer?
prime?
Can I just answer to Arham? Sorry. So Arham, what we are saying is, if you want to find primes, you need to go to these boxes. That doesn't mean that you have only primes in these boxes. There can be others also. For example, okay, I hope you get this, right? So
yes, sir.
Yeah, okay. So that's
35.
this is exactly what we have done here. Numbers not of the form 6x plus or minus 1 are these 1, 2, 3, 4. And we are saying that primes do not stay there, which implies that primes stay here. It does not imply that only primes stay there.
Yes, sir, I got it.
Right? So in case others have doubts, don't worry. Implication is the hardest thing in logic to understand. It's one of the most difficult things to understand in logic. Okay. Middle question.
No, sir, I wanted to see the solution, but
Okay. Kavin, if there is no question, can you also lower your hand?
No, sir. We can solve it by this way, but if we write the primes, first 6 primes, and then if we divide it by 6, we'll observe a pattern of 1, 5, 1, 5. With that, can we say that it is true?
So it says that primes, it says all primes greater than 3 can be expressed as 6x plus or minus 1. Somebody asked me in the chat, if P implies Q, why can't we conclude that Q also implies P? The problem is this. All numbers of the form 6x plus or minus 1 are not primes. right? Because we have 35, which is of the form 6x minus 1. It is not prime. We have so many numbers, 49, which is of the form 6x plus 1. It is not prime. So numbers of the form 6x plus or minus 1 need not be prime, but primes will always be of the form 6x plus or minus 1. Okay. Parul, question?
So just a clarification. So the 6x plus 5 resulting in a prime is nothing but 6x minus 1, but of the next multiple, right?
Correct.
Okay.
Let's try another problem. Prove.
Please
or
scroll
let
up so
me,
I can take a screenshot and I can copy.
yes. So let me ask you this, okay? T, the letter T is a positive integer. Okay, T is a positive integer. R, let us say, is an irrational number. Okay.
Sir, can you tell again what?
Sir, are you
The
writing
letter,
it, sir?
I'm going to write. I'm just here so that somebody wanted to take a screenshot.
I asked because I couldn't see. I just wanted
Yeah.
to test.
Yeah. So T is a positive integer. R is an irrational number. What can you say about R raised to 1 by T? Do a raise hand. Don't answer it. Do a raise hand. T is a positive integer. R is irrational. What can you say about R raised to 1 by T? Just do a raise hand. I'll give you a few seconds to think. It's not an easy question, so don't worry about it. Okay, I'll just call out a few names. Smrudil.
Yes, sir. Hello.
Yeah.
Yes, sir. Sir, if R is an irrational with the order being t, then R raised to 1 by t would be the R to the power t, R to the power 1 upon t square. If it has a different order, R has a different order, say x, then the number would result in some real number raised to the power 1 upon tx.
Okay. All right. Shreya. Shreya.
Sir, no, sir, I forgot.
Okay. Parul.
Sir, in a general sense, if you say x to the power of 1 by a or anything, it means the eighth root of x, right? No, I'm asking, I'm confirming.
Okay, so you're saying x to the power 1 by
a or something
is eighth root of x.
Yeah, it's correct, right?
Yeah.
Yeah, okay.
Kavin?
Sir, I have a doubt. In what sense are you, like, in what meaning are you asking?
No, I'm
R
asking,
to the power 1 by t?
can you say anything that you know for sure about
It's
R
an
raised to 1
irrational
by
number. It'll be an irrational number.
Okay, so you are saying this will be irrational. If anyone has a different answer, keep your hand raised, and otherwise you can lower your hand. Oh, I see. This is what all of you were saying. R raised to 1 by t implies that, R raised to 1 by t will be irrational, right? Now, naturally, others who did not raise their hand, they will ask this question, how do we know that? Right? So that is what we are trying to prove now. Prove that R raised to 1 by t is irrational using proof by contrapositive. Okay, this is your statement P, this is your statement Q. We are saying that T is a positive integer, or no, not, this is not P and Q. We are saying
R raised to 1 by t.
we are saying P is these two, T is a positive integer and R is irrational, Q is R raised to 1 by T is irrational. This is statement Q. Okay.
Sir, I think this is wrong. I think irrational is wrong.
What? Sorry?
I think R raised to 1 by T is always irrational is wrong.
Okay, just in the interest of time, it is irrational. Okay. Just in the interest.
Excuse me, sir.
Yes.
Sir, so we finished that last question, sir.
Sorry. We finished.
Oh, okay. So then we just have to end like because other possibilities are not true. That's why this one is true.
Yeah, so we are saying these are the numbers that are not of the form 6x plus or minus 1 and they are not primes. And that is what we had to prove. They are not primes.
Oh, yeah. Okay. Yeah. Right. Okay.
Coming to this. So this is our statement P, that T is a positive integer and R is irrational. Our goal is to show that, I mean, this is statement Q. We need to show that P implies Q to prove P implies Q. And we are going to do, our goal is to show that negation of Q implies negation of P. Okay.
Sir,
So
your P has two statements, and what will be the negation of P? Both statements opposite or only one statement opposite?
That's a very good question. That's a very good question.
T is a negative integer or 0, or
Sir, negation
R
of either is
One second. Urvi is saying something. One second. Can we take turns? Urvi complete and others want to speak, do a raise hand. Yes.
T is not a positive integer and R is rational, is what I think. Or R is rational.
So we'll have to think, when will this statement, what will be the negation of this? You know, just in the interest of time, I'm saying the negation of P will be T is a, you know, positive integer and R is rational. Okay, mistake, and R is rational, the opposite of irrational. Now you might say that it can be complex numbers, it can be some other numbers. So we are taking within the domain of
any of the both will be negation of P, right? I can tell that
no,
R is
no. So we cannot. So we'll okay. So you are saying T is a negative integer.
Means
is that what you are saying? T is a negative integer and R is irrational. That is
yes,
also
sir.
negation.
Or I can get that T is rational if R is rational, like that.
T is rational if R, no, there is no if over there.
No. Sir, if R raised to 1 by T is rational, then T becomes rational like that.
T is always rational. R is irrational.
No, sir, not only integer, it will become means non-integer rational.
Let me do it like this, okay? Let me simplify this. You know, I'm seeing that we are running out of time, so I'll make the question simpler. Statement P is R is irrational. Statement Q is R raised to 1 by T is irrational. You'll ask what is T? I'll say T is a positive integer. Okay, T is a positive integer. Now negation of P is R is rational. Okay, I think now there is no dispute. Okay. R is irrational. What is the negation of Q? Negation of Q will be R raised to 1 by T is rational. We are going to prove negation Q implies negation P. Okay, so I want you all to attempt that, and if your questions are clarified, lower your hand. If you want to give the answer, you can still lower your hand. Somebody who has a question, keep your hand raised so that I can address those questions. Siddesh, Mrunil, if you have questions, keep your hand raised. Kavi, if you have a question, keep your hand raised. Neil, question?
Sir, here r power 1 by t is not necessarily rational, right, sir?
R raised to no, that is the negation of q.
Yes, sir.
So we are saying if q is true, then negation of q is false. And if q is false, then negation of q is true. So these are statements. It is, don't go by, is it actually true or is it actually false? It's like, I'm making a proposition. Vinay is a man. This may be true, this may not be true. If this is true, negation of P is Vinay is not a man. If this is false, negation of P is Vinay is a man. Right? That's all that I'm saying.
Sir, I found a way to prove it.
Okay, congratulations. Wait, I'll take questions first. Urvi, you have a question, then raise your hand. Kavi, question?
If there are two statements, we should put in one statement itself. So we should put negation on those two statements.
Can you explain with this example what you mean?
So like P is T is a positive integer and R.
No. I changed that statement, Kavi. I said P is R is irrational.
So for example, sir, I am taking that as an example. Like if it is a negation of P, it is P is
Kavi,
not.
we can discuss that later. Otherwise, we'll get more into that implication logic, and we will not be able to focus on the proof structure of contrapositive, which is the agenda for this session.
Okay.
Anahita.
Yes, sir. So I just tried out with some numbers. Like
Do you have a question?
Yes, sir.
Okay.
That wasn't. Yeah. So like when I tried by root 4, like 4 is a natural number and root 4 is also a natural number. But when I tried with 2, root 2 is not a natural number. So that's where I just got confused a bit.
Sorry, what is R in your case?
Like the R, I'm not considering that R is I'm considering to be natural number, and R in my
R is irrational. It is given R is irrational.
So, sir, like cases for natural numbers and cases for irrational numbers set don't be the same.
R is root 2 is fine. You cannot take R is root 4.
Okay.
So R is irrational. Okay.
Yeah. Okay.
Yeah, the best possible case is just take R as something.
Sir, I think he's talking about the second case.
She just said she took this, so I'll just go with that. Kavi, you have a question?
Yes, sir. Like if we take P, sir, R is irrational. Negation of P is R is not irrational. So there is a possibility of complex number. So can explain?
I think I already said that statement, Kavi.
Sir, can you repeat it? Can you repeat?
Yes. So R is irrational. The opposite of that is R is not irrational, which does not mean R is rational. Okay, but we are considering R to be an element of real numbers. T is a positive integer and R belongs to the set of real numbers. Okay, so that is why opposite of irrational we are taking as rational.
Thank you, sir.
Okay, so how many of you think that you have got the proof? Can you do a raise hand? Kavi, can you lower your hand? All right. Okay. 5 hands raised. All right. So I want everybody else to think, how will we prove this? It will only be a 3 or 4 line proof, and we can discuss this in the doubts clearing. Okay. I'm going to give you one more problem to think about and try to work on it. Let me see if I have another problem. Yes, I have another problem for you. This is question number 2. A square plus B square equals C square, where A, B, and C belong to the set of natural numbers. Okay. Then A multiplied by B multiplied by C is even. We need to prove
I have
this.
proved this whole thing before. Actually, we have discussed this also.
have you done this by
Yeah,
proof by contrapositive?
No, not by contrapositive.
Right. So our exercise right now is to get a hold of proof. But see, whenever we are doing proofs, I know that you may have a different way to prove it, which is highly appreciable. But what we are trying to see is, can we think in terms of a given proof? Because that is the drill that we want to do, right? So prove that this is true using contrapositive. Okay, using contrapositive. And initially, there might be a lot of struggle in how to do this. So I want you to follow the structure that I said first. First, write the statement. What are you going to do? You are going to prove this by contrapositive, which means something implies something. What are those two statements? What is P and what is Q? And then what are you going to do? You are going to do negation Q implies negation P. Then write down what will be negation Q. And while you are doing all these things, you may have no idea how to reach the answer, but at least you start walking. You start walking the path. And then you see that somewhere it will get more clear.
So
Okay?
what do we assume as P and Q here? Q we got as A, B, C,
You
D,
need
and
to
what is
think,
P?
and you need to think in this statement, what implies what? What is P and what is Q? That is your homework. Okay, you need to think. We will discuss this in the doubts clearing, but you need to think on that. Okay, and if you don't get time to discuss, then I will post the solution in the Google Classroom later on. Okay, but think about this. I need to rush to another meeting, so I'll have to take a pause here.
Can you quickly go back to the previous question from where you left it, just so I can? Yes, sir. Thank you.
Here or down?
No. The irrational. Yeah, I got it, sir. It's okay.
Okay. Right.
Yeah, the next session is on 10:30, right?
Just check the timetable.
Yeah, it's on 10:30 for us.
Yeah.
Sir, I have solved this. Sir. Should I message it to you, sir?
Solve this using contrapositive?
Yes, sir. Yes, sir.
Yes, you can. You can.
Okay.
I'll try to check. I'm not sure if I'll be able to check and respond.
Sir, if you're not free,
sends.
then
You can send worst. See, you can send worst case scenarios. I will not reply. That's not a big deal.
Okay.
So don't worry about it.
Okay. I have a proof using contrapositive.
So you can send it to me, and if
for
I
both
can check,
questions, should I send, sir?
You can. You can.
Okay.
Okay, guys. See you in the next.
Sir, can you at least tell what is P
Thank
and
you,
Q
sir.
in the A square plus B square equals C square?
I would want you to think about it. Okay, let me do this. Let me say this. Think about it till 10:30, and if you still have a doubt, you post that in the WhatsApp group, and somebody will respond. Okay.
Okay.
But think until 10:30 and see if you can work on it.
Bye, sir.
Bye, everyone. Bye.
Bye, sir. Thank